Hello and welcome to another episode of the Fully Charged Plus podcast. Really wonderful conversation this week's episode. I know you're going to enjoy it. It was just one of those momentary things where out of the blue I managed to arrange this really delightful man that I met called Jan Rosenow. And Jan works for the Regulatory Assistance Project. That's his full-time job. My goodness, he does a lot of things, but his full-time job, he's working at the Regulatory Assistance Project, which is based in Brussels, but it's a global organisation, and they work on building peer-to-peer relationships. I'm quoting from their website because it's quite complicated what they do. They build peer-to-peer relationships and helping energy and air quality regulators and non-governmental organisations navigate the complexities of power sector policy, regulation and markets. Oh my lord, because the complicated relationship between all the different electricity markets around the world and the consumers and the distributors and the national grids and the grid infrastructures and the power plants and the fact that there's this developing technology of renewables, and some of it is on people's roofs, and the whole, there's an enormous amount of regulation that goes on in this field, and it's really complicated, and it needs any help that you can. But what is amazing is Jan is in the middle of all that and really understands how those businesses work, which particular technologies are really working now, are economically viable, which ones are maybe going to take longer to develop but have still got a really good role, and some technologies that are basically a fossil fuel con job. And we talk about all those, and it's a really interesting conversation. Managed to arrange it at the last minute last week. It was really kind of Jan to invite me into his house. He made me a cup of tea. We sat in his kitchen, and it was all very, very lovely. So that's this week's show. Before we start, just a very quick word from our fabulous sponsors. Over to the sponsors. My Energy is putting the I back into British innovation. My Energy is putting the I back into inventing the future. My Energy is putting the I back into inspiring a nation. Recharging the world with green, smart energy. Charge your EV with your PV and more. Visit myenergy.com and help to spark the green revolution. My Energy, driving the charge to a greener future. Thank you so much for your support. That's amazing that we are able to continue doing this podcast. We're very much reliant on our sponsors for that. We've been making these shows now for a long time. A lot of people listen to them. I'm hoping people continue to. Do tell your friends and family and people you know about the Fully Charged Plus podcast, because it is growing and it is wonderful. And I think this episode is a very good example of how grateful I am to have the access to the incredible people that I managed to get in touch with and hassle to be on the show. And it's always a great privilege. So without more ado, please welcome Jan Rosenow to the Fully Charged Plus podcast. What I've done is written a list of the groups that you're involved with: the Environmental Change Institute, the Royal Society of Arts, Manufacturing and Commerce, which I've heard of that one, the Coalition for Energy Savings, I'd never heard of that, and the Scientific Policy Research Unit. So that is a lot. You must be very busy. But can you tell me what your role is? Do you have an academic role in Oxford that I've probably completely...
Yeah, that's right.
Right.
I've been a PhD student here many, many years ago,
right,
about a decade ago, and have been an honorary research fellow at the Environmental Change Institute at Oxford.
Right.
Working a lot with Nick Eyre,
right,
who's a professor in energy policy, and he's been my mentor, I would say, in this space. I have a role here in Oxford, but that's not my day job. My day job is actually in Brussels. I haven't been for a year and a half, but I run a think tank called the Regulatory Assistance Project.
So there's more than I've got on
that list.
That's
my day job. That's my main
That's
role.
your proper
That's
job.
That's my proper job. That's right.
And so, sorry, repeat that. What it's called, the
Regulatory Assistance Project.
Wow.
And it's about 30 years old now. It was
Right.
founded after about around the time of the Rio conference in '92, and the name kind of says what it does. It's a project now as an organisation to assist regulators, policymakers to craft better policy to accelerate the transition to clean energy.
Oh, so it is energy focused, or I mean, it's not just all policy.
It's just
very
energy.
specific.
It's just energy, and it's about clean energy, decarbonisation.
Wow.
That's the mission.
I'm shocked that I've not heard of that, but then I do live in this country, which, as we both know, is slightly blinkered when it comes to some aspects of the European of the EU. I don't even want to go. I don't want to talk about the B word. Can't be bothered.
We also work in the UK. Actually.
Right.
We don't really care about what institutional setting determines. We just work wherever we see opportunities. For change.
Because it's quite interesting to get your perspective. So a lot of the energy companies I've worked with, the national grid, that I've spoken to, there's an overall kind of slightly self-congratulatory attitude in the UK that we're doing quite well, and it always makes me anxious. Because we've got an enormous amount of offshore wind, which is owned by Denmark and installed by Danish companies generally. It's kind of going, so it's very easy to say these things, but in general terms, I want to go on to many other topics, but do you think the UK is actually doing relatively well in terms of the amount of renewables that we are installing having installed?
The UK is generally seen, I think, as a place where there's a lot of innovation happening. From other places outside of the UK, is always, even after the politics of the last 5 years, people still look at the UK as a leader in energy very much. That's not in all areas. I think in electricity, for sure. I mean, the decarbonisation of the power sector is pretty phenomenal. Of course, Sweden far ahead, Norway far ahead, but they had different starting position. We had, I remember when I started working energy in the UK 15 years ago, the average grid factor was, I think, more than 3 times higher for carbon emissions. We emitted 3 times more carbon for each kilowatt hour of electricity than we emit today, and that's an amazing.
That is an incredible change. Yeah, it is extraordinary. And the amount of coal, because I've become very aware when coal went to sort of zero for a few days, and then it's only 2%. And I didn't realise it was when I first had an electric car, it was about 40% of the electricity we produced was from coal. Now, I did not know it was that high then. I'm really shocked.
Right, and now when I think it was a couple of weeks ago, a coal-fired power station had to be turned
back on,
and people, it was a scandal. We had to turn one back on, whereas 10 years ago that was
normal.
A very significant contribution to electricity generation.
But then, so overall, because one of the most inspiring conversations I've had was with a politician in Berlin about wind power. So I now, of course, can't remember who it was, but they were they had been at some big conference just before I met them about how you tie the whole of the European Union together so that when it's windy in North Germany and it's still in Italy, you can still compensate for that. How you would, and with solar and all that stuff, that kind of big picture. And is that still happening? Are moves still going towards that?
It is still happening. Right. Of course, the European Union has its own policies around the single market, and there's the energy market. There's lots of regulation and laws around it to integrate, across the different countries, because the larger the area, the more resources you have, the more flexibility you have, and the lower the costs will be of decarbonisation. But the UK is still plugged into all of that, of course.
Until
recently,
we had a fire in a huge. Well, I don't think you can call it a substation, a connector. I think they're enormous. An interconnector. But that's rather awkward. I wondered whether that was sabotage. I think it probably wasn't.
Well, we got to do more of that for sure. And you can see that there will be days when it's extremely windy and the UK can export electricity, and there will be days when actually we need electricity and other countries can provide that electricity. So I think that is still a project that makes an awful lot of sense.
Oh yeah, and I know we've just, because National Grid have been talking about it a lot recently, we've just installed this huge new interconnector from Northern England to Norway. So, and the idea being that we could use Norway as our battery, because we could export wind power when we've got loads to pump water up their mountains.
Absolutely.
They've got a lot of mountains. It's just very unfair. Not many people, loads of mountains. We've got a lot of people and very few mountains.
I looked up the percentage of non-renewable power in Norway. It's 3%.
Right.
97% of the electricity in Norway is from renewables. It's absolutely stunning. And a lot of that is hydropower, as you say, and that they have a huge benefit of having that resource. but it shows what is possible.
Yes. Yeah.
It's quite something.
So the other things I think you've mentioned, and one of them I've become slightly obsessed with recently, is carbon capture and storage. And I've tried to be open-minded about that. And I remember seeing a demonstration unit, carbon capture and storage unit in Imperial College. So at a university, which is an Imperial College, amazing reputation as an engineering university. But that was possibly 12 years ago. And it was huge. And that was like in their building. Like, they had a whole thing installed. It would have cost millions of pounds. And they could show how you could capture the CO2 from an exhaust flue. But I don't know. I mean, more recently I've been hearing very sceptical opinions about that, because it's being used as such a kind of a solution to a lot of the problems we have. I mean, is that an area you've dealt with?
Yeah, I mean, yes, and my sense is that it's very difficult to dissect the arguments, because clearly there is an industry that currently relies on oil and gas, and they have a very strong vested interest in keeping their existing business model running. And the whole idea of using CCS to make blue hydrogen, for example, offers sort of a lifeline and offers that opportunity potentially. And of course, they will make some very big claims about the amount of capture that is possible, how quickly this can be scaled up. But we have heard that for coal, a long time ago. That I think 30 years ago, there was this huge debate about CCS ready coal power plants, and they're all going to have CCS clean coal, right? And I checked just last week, as I'm writing a piece on blue hydrogen and CCS. How many commercially operating coal power plants do we have in the world today with CCS? There's just one in Canada. That's the only commercially operating coal power plant with CCS. And even there, the capture rate is very, very low. It's nowhere near where it would need to be to make it clean coal. So I'm sort of skeptical of some of the arguments. I know that there is technology out there that people like Michael Liebreich have promoted, that is more advanced, potentially could offer higher capture rates. But even Mike Liebreich would admit it's never going to be 100% capture. There's always some emissions that escape. And then, of course, we've seen the New York Times reporting on the Stanford and Cornell paper on blue hydrogen that was all over the place. And they say, of course, it's even worse than burning natural gas. I'm not going to sort of criticize all the assumptions they made, but even if you take the kind of more optimistic vision of that and the more pessimistic version, you still have residual emissions somewhere in the system. So it's not zero carbon.
I mean, that is the problem. And the other one that I've read about recently was the system that's operating in Iceland, that's just come online in Iceland. And I was going, that's impressive. And I read about it. I see it can capture 4,000 metric tons of carbon a year. And then what we actually need to catch is about 1 billion a year. If we could capture 1 billion tons of carbon a year.
It's a few hundred cars, something like that.
It's nothing. It's absolutely. But also, why is it then I went, why is it in Iceland? Because Iceland's own CO2 emissions from a global point of view have got to be fairly small. And why have they put it there? Because it uses a vast amount of electricity, and they've got effectively close to free electricity, very zero carbon. If you put that same installation in, say, Poland, it just doesn't work. It doesn't work.
Life cycle emissions. But what I would say is that I'm not dogmatically against any form of carbon capture, but if we do it, we got to make really sure that the emissions are captured properly, and I think that there's still the risk that how are we going to make sure this is going to be stored for decades to come safely? I don't think we have experience with that yet. To really be sure that there won't be leakage. So I'm just skeptical. I think green hydrogen has a much more much bigger role to play in all of this, because that can truly be zero carbon if it's made from renewable electricity.
I mean, that is all those debates. This must be, this is your world. All those debates about where there's the solution. And I think what I get upset about is not the actual technology, not even the idea of blue hydrogen, even the fact that that's probably being funded very heavily by the fossil fuel industry for perfectly understandable reasons. They're a business; they've got to keep going. But I think it's the press interpretation, and it's the level of ignorance in, proper journalists who've got proper jobs, who've gone to university, who can read things, and it makes me anxious, because it's the one area where I've focused my interest for the last 10, 12 years so I understand some aspects of it, and then I read a story that is so wrong, so completely, hopelessly bogus. And I think, well, if that is a topic that I know about, and then I read something about healthcare that I know nothing about, I believe that. Right. Well, I don't anymore. I'm slightly more skeptical. But that must be triply frustrating for you, where your understanding of it and knowledge and experience is way more than mine.
I would say there are some journalists who really go deep into the subject matter, research the topic well, they fact check, they write a good piece of journalism. They still exist. But there's also quite a few stories where you think, they've just copied and pasted something from a leaflet somebody gave them and haven't fact checked any of it. And I mean, especially with hydrogen, I think that the risk is that we kind of say it's going to come in 15 years or 20 years. Let's not worry about decarbonizing our heating. Let's not worry about burning more fossil gas, because at some point there'll be hydrogen.
We'll all be running on hydrogen.
Exactly, but I think it's the same with cars, right? Let's continue with the internal combustion engine. It will be running on hydrogen. I think the danger is that there is an element of magical thinking in there that we've seen before with other technologies, and I'm just not persuaded that we can sort of this time be sure it's going to come. So I think we have to be, I think, just sensible about this stuff and do the things that we know will work and are proven. And by all means, do more lab testing and trials and see whether we can bring costs down. But right now, it's simply not available. You can, I think 0.7% of global hydrogen production is either from renewables or with some form of carbon capture. 99.3% are from fossil fuels.
Because I've been saying 95%, thinking I hope I'm not exaggerating. I'm nowhere near bad enough. It's nice. So you're saying, say that again, it's 0.7%.
That's from the IEA's Future of Hydrogen report. That's where I got that number from.
That is wicked, isn't it? Because it is that, because people will nod and go, well, obviously you can get hydrogen from splitting water, which you can. I mean, I've done it on a TV show to make a hydrogen-powered gun. It does work. But it's, I didn't then measure how much electricity we were putting in the water to split the hydrogen and how much hydrogen we got out, but all the estimates I've heard, that's the other problem with
the efficiencies.
The efficiencies, which I feel that's unfair to judge that now, because that could very likely improve. There could be new technological developments that could mean it's about 4 to 1 from what I can tell at the moment. You put 4 kilowatt hours in, get 1 kilowatt hour of energy out, which is quite bad. If I think of, you and I know we put 4 kilowatt hours of electricity in our cars, we know how far that'll drive us, quite a long way.
Right. The efficiencies are just fundamentally different. And even though, as you say, there will be some improvements, the thermodynamics just limit the scope for improvements quite significantly, and it will never be able to beat, let's say, an electric vehicle or a heat pump by using hydrogen on efficiency terms. Certainly not.
God, there's so many topics I want to ask you about. Let's put heat pumps. I want to do heat pumps in a bit. But so the battery technology is the one that I honestly was when I first got a Nissan Leaf. So there's a Nissan Leaf just like mine parked opposite your house. That era Nissan Leaf. That I was definitely thinking, where do these batteries come from? All those doubts and fears, and they were, I think, very justifiable then. I mean, the battery pack in that car cost about $1,200, $1,300 a kilowatt hour to make that battery pack, and we know now it's about 140 now, and it's going down. But the development in batteries in that 10, just coming up to 11-year period is mind-boggling. But that's, I mean, is that an area that you've been involved in discussions about next generation batteries? There's certainly an iron air. Iron air is one of the big ones, not for transport, but for static storage, for grid level storage. I mean, is there discussions around, cheap, common materials, cheaper batteries for things like grid storage?
Yeah, I mean, I think that the other question is, of course, what do we do with the car batteries once they come to the end of their lives? Do we still use them? Can we recycle them, or do we just repurpose the battery and use them for grid storage? And there are already pilot projects out there. But for sure, there is now a need for much cheaper forms of storage and much more storage than ever before, because we have more renewables on the system and we need more flexibility, and storage can provide some of that. I think we're going to see a lot more innovation in that space going forward. So I'm an optimist. I think there will be things that we can't even anticipate today, like the fall in battery costs over the last decade, which is really phenomenal.
But if you think of for the last couple of weeks in the UK, the wholesale price of electricity has been mind-bogglingly high because of gas, because of the interconnector burning out, all those things. If we were to have battery storage that would get us over a period like that, it would be, I don't know what it would be, multiple petawatt hours. It's mind-boggling amount of electricity, which I can't quite, because that's, I think, I'm not suggesting that is what we need to do, because actually what you want is the buffering. You want to level out that demand curve. That's the thing I try and communicate to people who have never thought about it before. Don't worry about anything else. Just look at this shape. And that top bit of that spike, when we are like that now, where we are at this time of the day in the UK, that spike is the dirtiest, most expensive electricity we ever do. And the more we can bring that spike down, which isn't that much electricity in terms of weeks of electricity, it's a few hours.
Yeah, and when sometimes I hear people say, electrification of passenger vehicles or heating, it's seen as it's a problem. It just adds more load to the system.
Yeah.
I mean, the way we look at it is that it adds more load to the system, but it's incredibly flexible load.
Yeah.
I mean, EVs more than heating, but it's incredibly flexible load, and we're going to need an awful lot more flexibility if we're going to add a lot more renewables to the system to be able to kind of follow the generation from renewables. And a colleague of mine who works on energy markets, he always says, we used to schedule supply to meet demand.
Right.
We're going to have to schedule demand to meet supply.
Yeah.
And most people say, well, that's never going to be possible. But actually, there are some really simple things that one can do without interfering at all with the needs of customers, of consumers. You could say, I want my car charged at 8 o'clock in the morning, but I don't really care when it gets charged. And if you turn it off between certain hours of the night, I don't care.
Or if you take a couple of kilowatt hours out of it, as long as you put them back, which is, I mean, that's the technology. I mean, there's some, that's another topic actually, the vehicle to grid notion, which, when I first heard it, I went, that's it. That's the answer. There's no more problems. Everything's solved. Electric cars will save the human race. Since modified it a bit. I mean, partly from talking to people at the National Grid who go, I don't think that's going to be really difficult. With fleets, they're absolutely all for it. You've got 5,000 buses parked at night. Use that electricity that's in those, and then charge them up when you can do it. Although the flexibility you've got with that, and with fleets of delivery vans and taxis and all those things, it could work. They're slightly more sceptical about us, like you and I, with electric cars.
Well, I mean, you could see a role in incidents like obviously also in Texas in February, right, where you have really severe constraints and rolling blackouts. Your battery outside in your car could probably cover you for a couple of days, maybe 3 days or 4 days if it's a really big battery, which is more actually than a Tesla Powerwall can provide. There's a lot more kilowatt hours in there. So in extreme circumstances, you may well want to use that as a backup. And if more people have electric vehicles, that actually could be an option. I talk to people who work in the battery industry about this and saying, well, if you have that many cycles, you do that on a regular basis, you might actually run down the battery faster. You have more cycles, but if you use it only in certain instances, sounds to me like that is certainly an application.
Well, also, if you think of the stress on a battery in a car when you're accelerating, it's a phenomenal amount of power going out of it very quickly. And when you turn on a kettle, it's the equivalent of you sitting at the traffic lights. Basically, it's virtually nothing in comparison. So it's a much gentler use of the battery, from what I can. But I mean, that is one of the things. But I think it's interesting that they are now, Nissan and Hyundai for a start. Those two are definitely pushing vehicle to home, I think, initially. And even the car I'm in today, the Ioniq 5, has a vehicle to load capability. So it's one of the things I've got to do tomorrow when it's on display in Brighton. I've got an electric kettle, so I'm going to boil the kettle from the car and make a cup of tea. So you couldn't run your house on that yet, but they are now going to be supplying Hyundais to a project in the Netherlands, which we're going to go and see soon. Which will run houses, they'll proper vehicle to local grid, I suppose, rather than the national grid. But I think that will come in the future. I mean, have you ever done sort of work on? Because I know there's a massive grid battery in Cowley, isn't it? It's just been installed recently. I really want to go and see it.
Super Hub.
Because that's not open yet, is it? It's not
yet.
Right. Because that, interestingly, okay, so I'll explain to our listeners. I'm in your lovely house in I'm going to say East Oxford, and it's quite a narrow street. Victorian houses, quite a narrow street. There's quite a lot of electric cars on your street, which I'm really impressed with. But and you seem, all your neighbours seem to have managed to find ways to charge them. But actually, if you could drive down the road once a week and plug it in for 10 minutes, have a cup of coffee, and not have to worry about it, I don't know if that's an advantage, but it kind of strikes me as being a bit of one.
It will be for some people. I mean, some people simply don't have if you live in a flat, and
you can't do it.
You don't have any parking space outside, and where you could charge, then it's difficult. So for them, it will be useful. I mean, to be honest, on streets like this, we have a controlled parking zone, so there's always a free spot somewhere, and people usually respect. They know you need that spot for charging. At least on our street, that has never been an issue. We even share. We all know each other. There's a WhatsApp group.
So you could park outside one of your neighbours' homes and they
charge
unplug there, and they would do the same here.
Yeah, they would do the same. If there was an emergency situation, most of the time we can just charge at home. It's not a problem.
Right. Which is, I think that if you think of it in those terms, it covers, at the moment, I mean, the government figures I'm aware of, it's about 60% of people have got somewhere off the street to leave a car, which means 40% don't, of households, it's not individual. But what your arrangements you've got here, that could take that 40% down to probably 30. There's a 10% buffer where people, they're parked on the street, but actually you've got the access. If you can feed a cable under, because there's no trip hazards. There's no cables lying all up in the trees and coming down. You've kind of buried them in the pavement, and that's.
I'm sure that some clever people will come up with.
There are solutions emerging, aren't there? But that's. But then, so okay, give me the big picture on the electrification of transport, because that's often the overarching aim is to reduce our CO2 as the human race, is to reduce the amount of stuff we burn, because this is the kind of key for me. Is when I understood that, I went, if we could stop burning stuff, that's our little motto, that would be really good. And obviously you don't have to be that clever about engineering, manufacturing, physics to know it's very difficult to not burn anything, to do the things we do, but there's a huge amount of things we can do without burning stuff, and that's what turned me on to electric cars in the first place. You can charge them, you can drive a car, and you burn nothing in the whole process of making that journey. But is that discussed? I'm just wondering, like at an academic level and with all the research groups and the organisations you're involved with, is that a topic that's on the agenda?
Oh, absolutely. I mean, the main reason I think is that the direct use of renewable electricity is by far the most efficient way of using energy. If you combust a fuel, there's always a lot of losses in the system. By default, you've got waste heat that escapes that you can't use. And if you use another route, let's say we talked about hydrogen before, you have losses. We talked about this. So that's why electrification is attractive. But of course, what is important is that we also, at the same time, keep building out renewables, because we've got to keep the pace with the electrification, and the load that we add to the system needs to be matched, or more than matched, with a new generation capacity from renewables. Otherwise, all we will be doing is then producing more electricity with fossil generation, which is still better than burning the fossil fuels directly in the vehicle. But you don't get the carbon benefit that we need to see. So you need to keep building out renewables at a similar pace or more to really bring down emissions.
And are you generally optimistic about that development? I mean, is it? Do you see that as still happening? It's not kind of grinding to a halt, the development or the installation of new renewables.
No, I mean we've seen I think record deployment of renewables across Europe, not just in the UK. Way more than was ever thought possible. I remember the Green Party in Germany. I think in the early 2000s they were saying we can do 10% of renewable electricity by 2010, and they were laughed at. The last time I checked, Germany generated more than 50% of its electricity from renewables. That is only a few years after 2010, when the Green Party said 10% might be possible. So we've seen, I think, much more happening much more quickly on electricity, and I think that is really encouraging. But we got to keep doing that at an even faster speed. I mean, now people talk about not just in Europe, but also the IEA, full decarbonisation of the entire electricity sector by 2050. 2035.
Right, which is really
2040
soon.
at the latest.
Yeah.
That's it, 14 years, 2035. It's not a lot of time, and there's a lot of work to be done. But I'm optimistic that we will bring down emissions fast from electricity.
Because, I mean, that is the thing that I get sort of, I think, optimistic about, particularly when I talk to young people, is that the excitement, I've said it a couple of times to like school groups. This is in the olden days when you could do things like that, or students. There would have been a time, I do it from a personal point of view now, I spoke at a conference about the national grid and the energy sector in the UK, and there was an award ceremony, I did that, and I actually said at that event, if I'd done this event 20 years ago, I would have been asleep now. It would have been the dullest event you could possibly go to. Oh, the consumer has to be serviced by the industry, and we're going to keep moving forward, going forward again. All those horrible sort of corporate cliches. That event was an explosion of technology, of research, of possibilities. We're going to try this, it's a really exciting time, and from the point of view of engineering, science, technology, development, manufacturing. It's an incredible period. It is an industrial revolution, really, isn't it?
It is, and I think what we're now seeing is the next. I mean, we've done electricity, not completely, but we've started doing that. We know we can do it. There's still lots of hurdles, but I think most people who work on that are optimistic. I think the next step is transport. We started doing that. Electric vehicles. You can really see. I mean, the latest sales figures are just phenomenal. Wherever you look. I mean, Norway, of course, are almost now approaching, I think, 100% sales. But even the UK, other markets in continental Europe doing really well. I think the next step now is heating in the UK, and we haven't talked about that yet. But that's going to be the next step. It's even harder, I think. Electricity was relatively easy. Very painless for consumers. You still get electricity. Prices haven't really gone up all that much. Bills have stayed largely flat. Although most people don't know that. Especially politicians, they always assume they have gone up, but most bills are stable.
Roughly the same. So heating. So I'm a very good example of that, of someone who is desperate and obsessed, and I still have a gas boiler. I mean, I think it will go this year. But that's been the hardest thing to do. So my electricity use from the grid as a house is minuscule. I've really removed the burden of my house off the grid. So certainly at peak times, I never use grid electricity because I've got batteries, I've got solar panels, I've done all that. Right. But the heating, which we really don't use very often because the one thing we did right was insulate the house when we did work on it. So it's well insulated home and we don't use it often, but it chews me out that I still have. It's LPG because we're in a rural area, and I'm desperate. I just want to film the day the crane comes and lifts the LPG tank away because we don't need it anymore. But that has been a real challenge, and that technology, it feels like heat pumps, heat batteries, all those things. They exist, but it feels like just pre-Nissan Leaf. There isn't that. When I saw the Nissan Leaf, I went, an electric car that's made by a car company that are manufacturing them, and it didn't used to be a petrol car.
Right.
They haven't I want something that there's a box, and it's this thing, and you put it on your wall, and it's electric, it's really close, but it does feel like we've still got quite a few steps in there.
We still have a lot of work to do, but I'm encouraged by lots of things. I mean, there's now a debate about the topic. Right? That's always the first step. Having a debate and recognizing that it is a need for change. And that is so important because the vast majority of the population still don't really think of heating as an issue. I think that's changing right now. But all the surveys that have been done, when you ask people, what do you think most of the emissions come from? Where do they come from? People usually say, it's flying, or it's eating meat, driving a car, also comes up. Heating comes very, very at the bottom of the list.
And actually, it's
really
a
high.
huge chunk.
It's actually personally for a lot of people that is the main area where they contribute to emissions. It's heating, and if they could change one thing, changing that would make a huge difference.
Well, if you think about the time you spend in a car versus the time your heating's on, that's one way of looking at it.
Right.
You're not in a car very often and for very long. It's very unusual to be in a car all day. It's not unusual to have your heating on all day in the winter here. So.
It's a huge challenge, but I think what we see is now that there's a lot of investment, a lot of new innovations coming out, and sure, people discuss how long will it take until costs come down, and what's the right technology in which setting. But that's good, right? We need that debate, we need that innovation, we need to have different people try different things. some things will fail, others will succeed, and I think it's a really good step that we now actually have an active discussion around this.
Yes, yeah. Because I mean, it is also, when I first saw heat batteries, I went, oh, that makes sense, because you can heat that up when electricity is cheap, and then you use the heat. You can shift, in a sense, shift the energy, and those little things like that. And it's just, at the moment, is the expense, and I'm trying to work out how much of my pension I cash in to buy that, because I've now reached a point where, look, if I'm going to do this, it's never going to pay off. I'm not going to live long enough, but it's worth doing because I'm interesed in it.
I mean, you can also. I mean, I think of my house as a heat battery.
Right.
Yes. We insulated most of it.
Because have you done this house? Because we're in a beautiful room at the moment. People can't see, but it's a very lovely
this is
kitchen.
New build, triple glazing,
right?
Underfloor heating. The old part of the Victorian house, not everything is insulated.
No,
we still
it's very hard to do.
Some of it is, some of it isn't, but we're working on it. But all the windows have changed.
Right.
The loft is well insulated, and we can really use the house for. Switching off the heating during 4 to 7 in the evening when there's a lot of emissions.
Because it's already warm.
And maybe on a really cold day, temperature falls by half a degree.
Right.
Right. It's
nothing.
It's nothing. And you can even say, I want a little bit warmer before, and then you're still comfortable at 7 o'clock. So you can really think of your house as a heat battery. If it's well insulated, you can use that to store heat and avoid the peaks already. And then with a proper heat battery, one that you actually like a real battery.
Yes.
You can get several hours of storage, which makes it even more attractive. But of course, comes at an extra cost.
It comes at an extra cost. I mean, that was the thing. There is an amazing heat battery we've recently featured on the show on the Home series. And I went, as soon as I saw it, because I wasn't there, it was Dan who did the interview, and I went, I want that one. It's a huge thing. It's about £14,500. It's a small family car. It's
Is
that
it
kind of cost.
The Caldera?
I think so. Big tank, and it's got heated stone inside and that stuff. Which I love the technology of it.
Warm stone, I think.
Yes. I would love one of those, but I don't think I can quite stretch to 14 grand. To do that.
Well, I mean, if you say you have a well-insulated house, and actually, I would, and if it's probably a detached house somewhere in the countryside,
it is.
Ideally, you would probably have a ground source heat pump, but again, it has a big upfront cost. But that would be the ideal technology, because you use even less electricity than the heat battery. You use a lot of electricity.
You're going to use surely to get it hot. Yes, you will do. I mean, that's the when with the areas we've seen where this is the frustration with new home building, which I'm sure is the same. I don't know if it's the same all over Europe, I'd love to know. But we've been to a couple of big housing developments where they're going to build a house there. The land is all mashed up. They drill holes down into the ground. They do ground source heating for three. Each hole does 3 houses. They have solar panels. They're really well insulated. They build batteries in. It's got a car charger on the front. Before they've got the roof finished. Right. And you go, why aren't all houses like that? Because those houses now. And this is affordable homes in South Wales. They are the cheapest energy that anyone in effectively what we used to call a council house, an affordable home. Right. No one pays that little for all their hot water heating, everything. It's almost free for a large part of the year, and it's very, very low for the people who are the most at risk of fuel poverty.
It's an investment, isn't it? I mean, we have so many policies in the UK that deal with the symptoms of fuel poverty. Yes. Like winter fuel payments and the warm home discount.
Which is basically giving money to fossil fuel companies. Well,
in a way. It helps people in the short term, but it does not address the long term. So it doesn't really address a root cause, which is that we live in too inefficient properties. Yeah. And we use fossil fuel heating.
Because I don't know, I mean, because are you German originally? So I have the feeling that the obsession with old properties isn't the same in Germany. I may be wrong, but there is a sort of thing that you want to live in an old house. And because I grew up in an old house as a kid, that people wanted to take pictures of because it was a cottage in a village.
Beautiful, right?
We hated it because it was damp, it was cold, the roof leaked, it was bloody awful. Eventually when I'd left home, my parents did it up and it made it slightly more bearable. But that's what I think of as old properties. I'd much rather live in a new house, and some of the most amazing, like the what's the German term for the super well insulated home?
Passive house.
Passive house, which is a German concept. The first couple of passive houses I went to in Germany, I went, I want this one. That's amazing. Yeah. It's when you have a lever that opens the front door, and there's almost a hiss of air pressure. Because it's it fits so well. There's you you could put that house underwater and there would be no leakage. You know?
Well, you don't need any heating in some of these.
No,
because you get the solar gain from the windows.
Yeah.
You have the
Your
excess
own
heat from
body
your fridge,
is
your
heating
body,
it, yeah.
and you don't really need any heating. Very little.
Yeah, no, that is. But I mean, that was a game we played once when we were filming in Germany and we were driving on the autobahn. Was I Spy the houses without solar panels, which was quite hard. You can see them, but there's not many.
Depends where you're driving.
It depends where you drive, but then also this was long before you saw it very often here. I mean, there's far more houses, but it was at that time. Basically, Germany adopted solar much earlier, didn't they? I mean,
that's right, because of feed-in tariffs, they go, I think, early 90s.
Right. Yes.
It
was a German idea, wasn't it, originally?
Right.
Yeah.
It goes back a long time. And that led to a huge boom in solar. I mean, that's interestingly now you see that there's sort of smaller installations because you get rewarded for self-consumption. So if you consume the electricity yourself, you get rewards. But if you export to the grid, it's not really worth your while. So people are now optimizing, which is problematic, just for their own consumption. Whereas actually, if you have a big roof, you might want to use the entire roof space and maximize the solar because you can then export, and that's good for the grid.
Right. Yes, I see. But I mean, also, if you're not consuming from the grid, you're releasing the demand on it. I mean, you're lowering the demand, which I would think is not a bad thing. I mean, I'm fascinated by, and that must be another topic you talk about, is the knock-on, the sort of unseen, not necessarily negative, but the unseen knock-on effect. So I know, my wife is Australian, I know what's happened in Australia is that at the middle of the day, so it's completely different energy consumption patterns there. The middle of the day is maximum energy consumption. People put solar panels on their roof. The middle of the day is when they produce the most. The demand for coal, because of course they love coal, the government, has dropped to make coal so expensive and so uneconomic that the bills have gone up. So people don't want to buy electricity from, so they put batteries in the houses, which means they use even less. I mean, all that stuff. I didn't see that when I first thought, you just see it from your own perspective. I don't have to buy electricity now because I'm getting it from the solar panels,
Yeah.
But the knock-on effect to the industry has been really colossal, and that must have happened all over the world. I mean, it must have happened in Germany as well. Because those two things, this is really, we should wind up. How are we doing? We're doing all right. But the two things that remain are, which I hear all the time. One, Germany is just burning the dirtiest coal because they closed down nuclear. So the nuclear argument. And I think it's fascinating, the nuclear argument in Germany and France is somehow, I love it. It's exquisite and painful and awkward. But I'm about to drive through France and I'm going, it's going to be very low CO2 electricity that I'll be using when I go to the public chargers. That's, and there might be places in Germany where basically there's a massive hole I've driven past on the Dutch-German border.
Oh, the lignite mining.
Yeah, you cannot believe it when you're driving for like an hour and a half around one hole in the ground. I mean, it's just
miles and miles of...
so deep and huge, So I don't know. I'm very torn about nuclear power. I think it's safe, the actual generating. I think the storage of the waste is totally ignored and a massive global problem that we're leaving for our grandchildren and great-grandchildren and great-great-great-great-grandchildren. And I've never been convinced by any of those. And I don't know if you've ever been to Sellafield, but I've been around Sellafield a couple of times up in the north of England, where you look into a swimming pool that's like 400 metres deep, full of metal. And I'm really glad it's there, and I'm really glad the police who guard it with guns are there, and I want those scientists to carry on doing it because there's some worrying shit at the bottom of those ponds.
Yeah, I mean, nuclear is of course very controversial, especially in Germany.
Yeah. Because how old were you when Chernobyl happened? You must have been.
I was a child. I must have.
But it really affected Germany far more.
7 or 8 years.
Right. Yeah.
And it really triggered the whole movement against nuclear energy. I think looking forward, I think most people, whether you are pro-nuclear or against nuclear, I think if you look at it sensibly, it just takes too long to build them, and it's too expensive in the economics. So I just don't think that there's a future, at least in the UK, for massive deployment of nuclear power. No. It will take too long. We already see Hinkley Point, the costs start spiraling, and so I think even if you're pro-nuclear, you've got to admit that there are now other alternatives. They are cheaper, quicker to deploy, and should we shut down nuclear power plants earlier or later? I think looking forward, that is almost irrelevant. I think it's more about really doing the stuff that delivers emissions going forward.
Yeah, that's true. And I mean, I'm intrigued at what's going to happen in France, because they have I don't know how many, a hell of a lot of nuclear power plants, which eventually will have to be closed. Yeah. And I know that their nuclear waste facility, which is about 80 miles east of Paris, is full. And it's now being stored in sort of bins outside because it was in a cave or something. You just think that is a really rubbish way of dealing with this. It doesn't. That's what I've never ever heard of. I've talked to people who go, "Oh, we can use nuclear waste now in new generation of nuclear power plants." If you can, please do, because what else are we going to do with it?
Well, it's a legacy, isn't it, that we leave behind?
And that's what's it is terrible. And I mean, if you go the very worst aspects of wind turbines, the concrete in the foundations on land-based wind turbines, you go, I'm not so worried about that legacy. If my triple great-grandchildren had to go, oh, now we've got to dig up the concrete they left, that's not as bad. Yeah. Don't go near that mountain range because you will die, because it's just throbbing.
I mean, the point you made about wind turbines and concrete foundations. I mean, every form of energy generation has some negative environmental impact and a cost. And I think that's why it's so important to also be efficient with how we use electricity, how we use energy, which is often overlooked. I mean, you see people who claim, we will have an abundance of renewable electricity. We don't need to worry about it. It's going to be so cheap. We can make lots of hydrogen with it and just use it wherever we need it. And I think that is also deeply problematic, because there are all these other impacts, and we got to minimize those as well. We don't have an abundance of raw materials. We don't have an abundance of land. So we got to be wise how we use energy.
Yes, no, I think you're right. It is that struggle to use less, and that's one of the difficulties that when I've looked at, it really became apparent last year during lockdown that we just didn't drive anywhere. So then I suddenly went, oh my God, our electricity bills are non-existent. In this last summer, we just didn't pay for electricity because we made all the stuff we needed from the solar panels. It was in the batteries. We used that at night.
Brilliant.
Well, which is great, but when you've got 2 electric cars, which we do, it's basically another house, if not slightly more sometimes. That is a great increase. So our overall the year, on an average year, in the last sort of 5 years, I've used more electricity than I used to, but I also haven't bought any petrol. So
Well, our heat pump uses a lot more electricity than the car. So
does it?
Yeah, it does. If you
like an air source heat pump would use more electricity. Yeah. And you've got one here, right? So you're not. That's not a theory you've read in the paper. That's from experience.
I can see it. I can see the electricity consumption going up.
Right.
But that was always to be expected. Right? Because we're replacing about 3 units of gas with 1 unit of electricity.
Right. So is it cheaper than having a gas boiler?
It's not cheaper unless you run it on a time of use tariff, where it's cheaper to use electricity outside of peak times. Yeah.
But you don't really want to heat your house at 2 a.m. necessarily.
Well, I mean, to be honest, we've been doing it since the beginning. We let the system optimize the heating, so we minimize our bills. And we don't really heat the bedrooms much. You can still individually say, I want that room to be cold. I want that room to be nice and cozy that time of the day. With smart thermostats, it's entirely possible.
And is your heat pump, is that heating water that's in a wet heating system in the house? Yeah. So it's basically just replaced the gas boiler. I'm only saying this to explain to people how
it's replaced the gas boiler, and it does the same job essentially. It also provides the hot water.
Right. And this is an air source heat pump, right? Yeah. And so a ground source then is more efficient, uses less energy, gets more heat.
Right. And the main reason is that in the winter when it's really cold, the temperature in the ground is actually fairly constant.
It stays the same.
It's the air temperature that gets really cold, and then there's less energy to extract.
Right.
Although people always ask me, how can you still use energy when it's -5 outside?
You can.
There's actually energy everywhere around us.
Jan, I could talk to you for a lot longer, but I think I should let you get on with your life. But it's been real privilege to talk to you today. Thank you so much. And please, will you come and do the Fully Charged Show live podcast again, and come to the live events? Come and do
a panel
at the live events. It'd be really good. But it's been really, and I've just explained to our lovely listeners, this has worked so well for me. Fitted it in, so I'm on my way from home into London, and Oxford's about halfway, so it's perfect. I've had a cup of tea with Jan, and it's all marvellous. Thank you so much. It's been really good.
Thanks for having me.
Well, that was wonderful. Wonderful to talk to Jan. I had a look at his air source heat pump after we finished recording, and he showed me how he charges his car on a street where there's no off-street parking and all those things. Amazing, an amazing man to meet. I really want to get him to come on the show again and to come to Fully Charged Live next year in the end of April, beginning of May. We're looking forward to that. But that's all for this week. Please do subscribe, tell your friends, do have a look at the Patreon link if you're interested in that. Keep watching Fully Charged on YouTube. And as always, if you have been, thank you for listening.